In this video clip, I will show you how to perform multiple linear regression analysis in Excel. Multiple linear regression is a statistical method that is used when the data are normally distributed or the data are parametric data. The multiple linear regression is performed when there are more than one predictor, two or more predictors, and an outcome that is measured on a continuous level or a scale level, and a predictor that can be a continuous or can be categorical. The multiple linear regression method is performed to find out whether there is a relationship between a predictor, which is the independent variable or the explanatory variable, and an outcome, which is a response variable or the dependent variable. The objective of performing the regression analysis is to determine whether there is a relationship between these two or more than two variables, and whether the predictors can predict the outcome, and to generate a model to fit this predictor and to determine the contribution of the predictors to the variation in the outcome. And the way to do that in Excel, if you find this video useful, do subscribe to the channel, leave any comment in the indicated box, and activate the notification bell to receive the recent and latest release into the channel of several different video clips, and click on the like icon and share the video link with others so the channel can expand and improve to include a large scope of different statistical method and how to analyze data using several different statistical packages such as SPSS, Excel, Stata, Jamovi, RStatistic, or Statistics, GraphPad, Prism, GPower, Python, and RevMan. First of all, to install the package for data analysis, which is here, by clicking on File and then click on More, and then click on Options, and in the Options window click on Adds In. In the Adds Ins window, select the analysis tool pack and then click on OK. And as I've already installed the data analysis, then an icon for data analysis should appear in this area. And if you click on the data analysis, a new window will appear, and from that window scroll down to find the statistical test to perform, which is regression. Before performing the test here, let us look at the data. We have here three variables: the age, the weight, and the systolic blood pressure, and these data were collected from 100 participants in which their age and weight was determined, and the blood pressure was also recorded. The first variable, the age, is a continuous variable measured on a scale of years, and the weight variable, the second variable, is also a continuous variable that is measured per kilogram, and the systolic blood pressure, a third variable that is continuous. Here we have two variables or two predictors, the age and the weight, and the systolic blood pressure, which is the outcome. And to find out whether the age and the weight can contribute to the variation in systolic blood pressure, and whether the age and the weight, the predictors, can predict the outcome, then a model need to be established using the linear regression as the data here are parametric and normally distributed, then multiple linear regression will be performed since we have two predictors here, the age and the weight relative to the systolic blood pressure. And multiple linear regression will generate a formula, and from that and fit linear regression, and from that models an equation can be generated. To perform the multiple linear regression on these data, click on data analysis, select the regression statistical test, click on OK. In the new window here, for the input, select the Y. The Y is always the outcome. So if we select the outcome here and then the input for the X range, we have here two predictors, the age and the weights. Then select the weights and the age into that box here. Keep the labels for the age and the weight and the systolic blood pressure. Keep the confidence interval. Then select the output range. Select a place to insert the outputs, in this case here. And you could also go for residual. So tick on residual, standardized residual, residual plot, and line fit plot, and normal probability plot. If you click on OK, as shown here, an output is generated with multiple tables and multiple graphs or plots. In the first table here, a summary is given for the output, and as shown here, there is this is a multiple linear regression. The important value here is the R square and the adjusted R square. Since both the age and the weight are measured at a different scale, then the adjusted R square will be considered here, and this adjusted R square indicates that 58.4% of the variation in the systolic blood pressure can be explained by the age and the weight. So 58.4%, the age and the weight contribute to the variation in the systolic blood and can explain that variation. The second table tests whether the model fit, and it is an ANOVA table and shows that the p-value is less than 0.05. The third table is the most important table, as it shows the coefficient estimate here for the intercept and for the slope for the first predictor and for the second predictor. So this is the beta value for the age and for the weight and for the intercept. The intercept is the value of the value when the age and the weight is equal to 0, and the intercept is significant. What is significant here, as the p-value is less than 0.05, the age and the weight p-value is also less than 0.05, which indicate that there is a significant, and the slope and this value here, the coefficient, which is 0.92, is the slope for the age, and the 0.23 is the slope for the weight. So what does this values mean? It means that for every increase in 1 year of the age of the individual, there is an increase of 0.92 in the systolic blood pressure, and this increase is statistically significant as confirmed by the p-value and the lower and the upper confidence interval. The second predictor, which is the weight, also shows that with every increase of 1 kilogram of a weight of an individual, there is an increase of 0.23 readings for the systolic blood pressure, and this value is significant as the p-value is less than 0.05. So this table shows that the model is constructed including the predictor age and weight can explain the variation in the outcome, and this age and weight can contribute to the variation in the systolic blood pressure. And another table generated here for residual output, which is important, and a probability output. Looking at the plot here, again, this is the normality plot is produced, the weight line fit plot and the age line fit plot, and the weight residual is a very important also, and the age residual plot. So this is the way to perform multiple linear regression in Excel when there are two or more predictors that are continuous or categorical, and outcome that essentially has to be continuous, measured at a scale. If you are a student or a researcher and you have a data, whether it is quantitative or qualitative, and you want to perform statistical analysis on that data using any of the softwares listed here, whether it's SPSS, Excel, Stata, Jamovie, R Statistics, GraphPad, Prism, RevMan, GMP, Python, then do contact me to arrange for either a one-to-one private tutor session or a training course on any of these statistical packages. My contact details are given here, so don't hesitate to write to me or email me if you need a private one-to-one tutoring or a training course.